This lecture is about the binomial probability distribution, and it follows the introduction to probability and the exercises we covered previously. So we covered previously what's the probability if you roll a dice to get a 6, and hopefully by now you know that using the probability definition, the probability of getting a 6 is the number of ways you can get the success divided by all possible ways. Since success is just getting a 6, and since there is only one 6, so that would be 1 for the numerator, whereas for the denominator, knowing that you have 6 possibilities, you will going to divide by 6, and therefore the probability of getting a 6 would be 1 over 6. Now, if we were to roll the dice twice and or roll 2 dice, we can ask for the probability of getting 2 6s. So getting a 6 and then also getting a 6. And I believe in the previous lectures we have addressed that, but let's review that quickly. So the probability of a 6 and a 6, um, first thing you're going to ask yourself, are these two events independent? Yani, does the probability of getting a 6 on the second roll depends on what happened on the first roll or not? And the answer is that no, it doesn't. We're going to use the multiplicative rule this time. The simplistic form of the multiplicative rule. So let me show you what I mean by that. You may remember that we have covered previously that the probability of A and B is nothing but the probability of A multiplied by the probability of B given A. However, we said that in the case where the A and B are independent, then you can write it using the probability of A times the probability of B without the condition, because these two events are independent. All right, so let's go back to our lecture. Okay, so the probability of getting a 6 and a 6, hopefully it's easy, because what's going to happen is it's a 6 times the probability of getting a 6. The probability of 6, as we said, is 1 over 6 times the probability of also a 6, which is 1 over 6, and therefore it's 1 over 6 times 1 over 6. What if you're asked, or we are asked, to calculate the probability of 6 and a 5? Would that be the exact same thing, or would there be a difference? Though the probability of 6 and probability of 5 are exactly the same, 1 over 6, 1 over 6, what is different in this scenario, and I hope it's clear by now, that when we had a 6 probability of 6, it could only happen 6 and 6. These were the only one option we could have. However, when you're looking at the probability of 6 and a 5, you can start with the 6 and then the 5 could be the second one, or you can get the 5 and then get the 6. True that each one of them in each one of these is equal to the probability of 1 over 6, and if you want to replace it, it would be 1 over 6 times 1 over 6. However, you also have to account that there is this option that can happen, yani كمان 1 over 6 times 1 over 6. And if you want to combine them, this means it's the 1 over 6 times 1 over 6, and it's multiplied by 2. So here what is different from getting 2 6s in a row is that it can happen in 2 different ways, and therefore you have to multiply by 2. So this is just an overview. Let's continue. Here we have to account for the numbers of ways, and as I explained that, now let's make it more complicated. What if we're rolling a dice 3 times and I'm interested in 6? Now, how many 6 I can get if I roll a dice 3 times? If you roll a dice 3 times, you can get a 6 one time, or 2 times, or 3 times, or actually none of the times. So the possibilities regarding 6 is that for you to get no 6 whatsoever, to only get 1 6, to get 2 6s, or to get 3 6s. Okay, so let's calculate each one of these and see if we can um, get a sense of how this is done. So the probability of getting no 6 in 3 tosses, can happen only in one way. Remember, you're only interested in getting a 6. So everything else is the same for you. So what's going to happen is that you want not a 6, not a 6, not a 6. The way I've been writing this is something like that. So you are interested in not a 6 on the first one, not a 6 on the second one, and not a 6 on the third one. And this can happen only one way. So just find this probability, find that probability, find this probability. Obviously, they're exactly the same. We multiply them because they are independent of one another, and it can happen only in one way. Okay, so that is 5 over 6 times 5 over 6 times 5 over 6, which is 5 over 6 raised to the power 3. All right, what about the second one? What if I want to get only 1 6? Well, here you have to realize that this can happen in 3 different ways, right? Either the 6 is the first toss, followed by 2 not 6s, or the 6 is in the middle, and then you have not a 6 at the beginning and not a 6 at the end, or the 6 is the last one, and therefore you have not a 6, not a 6, followed by the 6. Okay? Now, in each case, the probability of 6 is 1 over 6. And in each case as well, the probability of not a 6 is 5 over 6, right? So actually, each one of these is the total probability is exactly the same. It's just 1 over 6 times 5 over 6 times 5 over 6. However, since there are 3 different ways this can happen, then I have to multiply by 3, and therefore I can write the probability as 3 times 1 over 6 for the 6, 5 over 6 raised to the power 2 because I have not a 6, not a 6. So come in quickly just because I have been using this previously, and if you want to see it again, then what I'm saying is that this can happen as 6 followed by not a 6 and then not a 6, or not a 6 followed by a 6 followed by 6, not a 6, or not a 6 and not followed by a 6. Okay? And if you want to calculate the probability of each one of them, you're going to discover it is 1 over 6 for the first one multiplied by 5 over 6 multiplied by 5 over 6. For the second one, you're going to start with the not 6, yani 5 over 6 multiplied by 1 over 6 because the 6 is right here, and then 5 over 6. And for the last one, it's going to be 5 over 6 for this one multiplied by, come in, 5 over 6 for that one, and you finish off with 1 over 6. And all I'm saying is that these 3 are exactly the same. You can rearrange them and you need to add them up because all of these are successes, and therefore you end up with 3 because there are 3 of them times 1 over 6. As you can see, there's 1 over 6 here, there's 1 over 6 here, and there is 1 over 6 there. And then you multiply by 5 over 6 raised to the power 2 because there's 2 of them here, there's 2 of them there, and there's 2 of them there. Okay? So going back to the lecture, so if you're interested in getting only 1 6 in 3 tosses, then this is what you're going to get. Now, getting 2 6s in 3 tosses, again, same approach. 6 6 not a 6, that's the first way this can happen. 6 not a 6 and 6, this is the second way it can happen. Not a 6 followed by 2 6s, this is the third way this can happen. And therefore, all of these 3 have exactly the same value, which is 1 over 6 times 1 over 6 times 5 over 6. And since they're repeated 3 times, you're going to get 3 times 1 over 6 raised to the power 2, right? Because I have 2 of them every time, times 5 over 6. And finally, if you are interested in calculating what if you're getting 3 sixes, well, this is also easy. This is where it can only happen in one way, which is 5 over 6 times 5 over 6 times, I'm sorry, 1 over 6 times 1 over 6 times 1 over 6, and therefore the answer is 1 over 6 raised to the power 3. Okay? Now, if I put everything together, I can look at it this way. So, as we said, if you toss the dice 3 times, you can get 0, 6, 1, 6, 2 sixes, or 3 sixes. That means the number of not sixes are 3. If none of them is a 6, then all of them are 6. Let me repeat again. I'm sorry, I'm making a mistake. If none of them is a 6, if none of them is a 6, then all of them are not 6s. If only one is a 6, then 2 of them are not 6s. If 2 of them are 6, then 1 is not a 6. And if all of them are 6s, then none is not a 6. So basically, all I'm doing here is I'm counting how many 6s and how many not 6s. Okay? And these are the probabilities that we just derived in the past few minutes. Okay? Now, let's continue a little bit so that hopefully you can start seeing where I'm going with this. So remember that the probability of my success, can it 1 over 6, my probability of the complement of it, or I can call it the probability of failure, is 5 over 6. Okay? So I call it this in green, I call it this in yellow. Also, the number of 6s, I colored them in red, and the number of failures, I colored them in purple. Now I say failure as the not 6, yani the complement. Okay? Notice what happened. In every case, I can write the probability as the probability of the success. The success in this example is getting a 6. The probability of getting a 6 is 1 over 6. Okay? So I can write it as the probability of the success, which is 1 over 6, and I raise it to the number of success. Okay? Then I multiply it by the number of failure, which is not 6. Raise it to the power of the number of failures. And that is going to be true for all of them, given that you're also multiplying by this number at the beginning, which is the number of ways this can happen. Okay, so let me back up one step. Maybe let me explain how I got these numbers. So if I go back one slide, you are fine with how I got these, okay? So I got these, and let me go to the drawing board and see if I can explain to you how I went from this all the way to down here. So let me start with the first one. So the first one I had 5 over 6 raised to the power 3, right? Okay. So the first one was 5 over 6 raised to the power 3. This was the actual probability, 5 over 6 raised to the power 3. Okay. Now, if I multiply this by 1 over 6, however, I raise this to the power 0, then you know that this value is nothing but 1, and therefore the entire thing didn't change. Also, I can multiply by 1 here, and therefore the whole thing hasn't changed. I can do that. And that's where this 5 over 6 became on the second slide as 5 over 6 raised to the power 3. That is the part that I got from the previous slide. However, I multiplied by 1 over 6 raised to the power 0 because that's a 1 and a 1 right here. So that's for the first row. Now for the second row, all I did is I added a 1 here. So 1 over 6, I raised it to the power 1, which is true. The second row, again, I raised the 5 over 6 to the power 1, which is what is missing here. And for the last one, I did exactly what I did for the first one. However, I multiplied by 5 over 6 raised to the power 0. and I added a 1 at the beginning. So let me show that to you again. Okay. So here, when I said that I raised it to the power 1, which you were not seeing before, but now you see it. Here I raised the 5 over 6 to the power 1. And the last one, I added the 5 over 6, I raised it to the power 0, and I added 1 at the beginning. And the idea from all of this is that I'm hoping that you can start to see a trend. Okay, so every time you want to calculate any of these probabilities, all you have to do is get the probability of the success. Now we define success to be to get a 6, which is 1 over 6. You raise it to the power of how many successes you're interested in. So notice like how 1 over 6, 1 over 6, 1 over 6, 1 over 6. And the first one is raised to the power 0. The second one is raised to the power 1. The third one is raised to the power 2. And the last one is raised to the power 3. So it's power of success raised to the number of success times the probability of failure, which is 5 over 6. Failure, yani not a 6, in our example. And again, it's raised to the number of failure. So if you had no success, all of them were failures, so that's a 3. So 3 for the first one, 2 here, 1 here, and 0. Okay? And the last thing, also, you have to multiply by the number of ways this can happen. Okay? Okay. So this is just what I just explained, except that I'm introducing the concept of calling success and failure, and the number of success and the number of failure. So once you decide what are you interested in, 6. So 6 is your success, and everything else is a failure, and therefore probability of 6 becomes the probability of success, and probability of not a 6 becomes the probability of failure, and the number of 6s becomes the number of success, and the number of not 6s becomes the number of failures. Okay? And finally, these numbers, the 1, the 3, the 3, the 1, like how many different ways it can happen, this is called the combination. Okay? It's a combination. Which takes us to actually the binomial probability distribution. So let's apply this in a general form. When there is an event that has two outcomes, two possible outcomes, that's it. Success, failure. Hala, notice that tossing a dice actually has 6 possibilities, but we are only interested in either a 6 or not a 6, so we turned it into a success failure. Same thing like any kind of event. As long as you can think about it as success and failure, even if the success is an aggregate of multiple things and the failure is an aggregate or everything else, it doesn't matter. You can turn it into success and failure, then that's what matters. Okay? So if you have an outcome that has two possibilities, and then you're doing a trial where you're repeating to look at the outcome, and the probability of success does not change from trial to trial, like tossing a dice or flipping a coin. The probability of head in flipping a coin does not change as you flip it the first time, the second time, the 3 times, 4th times. Okay? So if this is the case, we talk about a Bernoulli event. Okay, so then we have Bernoulli events. Bernoulli events like in short, two possible outcomes, success, failure, and the events are independent, meaning the probability of success doesn't change, the probability of failure doesn't change. And then, so we call the number of trials n. An example a moment ago, we were rolling the dice 3 times, and therefore the number of trials can 3. You call x the number of success, that therefore x, نحن in our example a minute ago, can يا 0, no success, or 1, or 2, or 3. Automatically your number of failures becomes n minus x. Okay? And the probability of success is, what is the probability of success in one event? Like tossing a dice 1 time, what is the probability of getting a 6? That's 1 over 6. Okay? And the probability of failure is the complement of that, meaning 1 minus the probability of success. And therefore, in our example, it was 5 over 6. So if we have this definition, the binomial probability becomes, if you're interested in knowing what is the probability of getting x successes out of the n trial, مثل ما كنا عم نقول a moment ago, throwing a dice 3 times to the probability of getting 2 6s. So you would be interested in the probability of 2 successes. Then it's the probability of the success raised to the number of success times the probability of failure raised to the number of failures. And then you have the number of ways this can happen. This is your combination, which is n factorial, the number of trials factorial, divided by the number of success factorial times the number of failure factorial. Okay, this is called a combination. Also, some people write it this way. Okay, now a factorial, basically, for those that haven't seen factorial, basically a factorial n factorial is nothing but you start with n and then you multiply it by the number that comes before it, all the way you go down to 1. Or 1 all the way up to n, it doesn't matter, it's exactly the same thing. Yani n factorial is 1 times 2 times 3 times 4 all the way up to n. And therefore 3 factorial is 1 times 2 times 3. 1 factorial is 1. However, you need to remember that 0 factorial is 1 as well. This is the only trick that you need to remember. 0 factorial is 1. And using this formula, you can figure out how many different ways something can happen. Okay, which brings us again to our um, binomial probability. If you have a Bernoulli event with an n number of trials and you're interested in x successes, then you use this formula. Therefore, let's look at this example. Taking from a deck of cards 1 card at a time with the replacement, what is the probability that if I repeat this process, out of 4 cards, 3 will be images? So the first question you have to ask yourself, is this a Bernoulli or not? To know if it's a Bernoulli or not, ask yourself, is the outcome I'm looking at it, is it success, failure? So I'm looking at here, taking a card from a deck of cards, and I'm interested if it's an image or not an image. So everything that is an image gets to be clustered together, and it's called a success. And everything that is not an image is clustered together, and it's called a failure. So out of 52 cards, how many are images? Remember, the images in the valet, the queen, and the king. You have 3 of them, but you have 3 of them for the heart, for the diamond, for the spades, and for the clubs. So 3 times 4, that's 12 cards that can be considered successes, leaving 40 cards as failures. So that's the first part of the Bernoulli. Yes, first part is met, but let's look at the second part. The second part says that the probability of the success of that event does not change as you're repeating your trial. So taking the first card, for the first card, the probability of image is 12 over 52. Okay? Now here's the key thing. We are replacing that card, meaning that I'm putting it back in the deck and I'm shuffling the deck. If I did not do that, if I kept that card with me and I went for another card, the probability of success of the second card would not be the same anymore. First, you no longer have 52 cards. Second, depending upon what you got as the first card, your successes are either 12 or 11. Okay, so if you were to do this with a deck of cards without replacement, the Bernoulli would not apply. However, since I'm putting back the card inside the deck and I'm shuffling the deck, therefore the probability is not changing, then yes, this can be considered a Bernoulli, and then I can start calculating the probability. So let's define the elements of that probability. The probability of success here image, and I just said it's 12 over 52. The probability of failure is not an image, which is 40 over 52. And notice that if you add them up, you get 1. How many trials do I have? How many cards I was going to pull and repeat every time, right? And 4. And I was interested in how many successes? We said 3. Okay? So this is the question. Now all I need to do is I start plugging in the numbers inside the formula. So here I will have 4 factorial. Here I will have 3 factorial. This becomes 1 factorial. Probability of success is 12 over 52 raised to the power 3 because I'm interested in 3 successes. The probability of failure, which is 40 over 52 raised to the number of failures, which is 1. So this is what I just said a moment ago. You do that. So by plugging and chugging, you will be able to get the answer to that question, which is 0.1417, 14%. And you can see that we were able to calculate a probability that previously we might have thought that it's complicated, but because now we know that we can use the Bernoulli distribution and the binomial formula, I can actually calculate that probability. So here's another example. In a family of 5 children, what is the probability that 3 are boys and 2 are girls? Okay, so here again you have to ask yourself the following question: is the probability of being a boy or a girl, is it considered a Bernoulli event or not? Um, well, um, yes, I mean, success failure, boys, girls, success failure, yes. And then the second part of the Bernoulli, are they independent? Yani, does the gender of the first child affect the gender of the second child? And the answer is no. So the probability of being a boy or a girl at birth doesn't change the probability of the second child. So that is definitely a Bernoulli. Okay, the events are independent. Now, which one do you want to call success and which one do you want to call failure? It's up to you. Doesn't matter. You want to call the boys' success and the girls' failures, or you want to call the girls' success and the boys' failures. It doesn't matter. What matters, once you picked your success, you stick to it. Yani, if you decided that boys in is success, therefore the number of success is going to be 3 and the number of failure is going to be 2. However, for those that decided that girls are the success, then the number of success is going to be 2 and the number of failure is going to be 3. And everything else is the same. Okay? So see if you can do it by yourself and see if you can get the answer. Here's another example. On the way home from school, there are 7 traffic lights. A traffic light is green 35% of the time, orange 15% of the time, and red 50% of the time. The lights are not connected to one another, yani they are independent of one another. Okay? What is the probability on your way home you will be stopped 2 times? Again, you ask yourself, is this a Bernoulli event? And let's say you're going to be stopped if the the light is orange or red. So we're combining the orange and red together to get a probability of being stopped. So that's your success. And not being stopped, that's a green. And this is the failure. So how many times do you want to be stopped? Or actually the question is 2 times. So your success is 2 and the 5 other times are failures because we have a total of 7 traffics. And now you can calculate the probability. I'm not going to do them here. Maybe we can do them in the lecture, or maybe you can try to do them by yourself and bring your questions to class. Some vocab when we're dealing with probabilities. When we say at least 4, yani 4 or equal. So when you say 4 or equal mean that you have to count the 4 and anything above the 4. When you say at most 4, it means that the maximum is 4. So meaning that you're going to count everything below the 4 till you reach the 4. And therefore, if there are 10 trials, and if you're asked to calculate the probability of at least 4 successes, for success, therefore you're going to calculate the probability of 4 success, 5, 6, 7, 8, 9, 10, and بما انه in between there is an or, it's a union probability, you're going to add these probabilities up. If at the same time you're asked to calculate, or if you are not at the same time, if on the other hand you're asked to calculate the probability of at most 4, this time you're going to get the probability of 0, the probability of 1 success, the probability of 2, the probability of 3 successes, the probability of 4 successes, and again there is an or in between, so you add these up. Okay? For example, if you're asked the probability of at least 1 success, قلنا at least يعني 1 and all the way up. So you're going to calculate all the probabilities except the probability of 0 success. And here it might be easier for you to do 1 minus the probability of 0 success. So instead of calculating 9 probabilities, all you have to do is calculate the probability of 0 and you do 1 minus the probability of 0. At most 9. يعني كل probabilities are included except 10, and the same idea is applies. You're going to do 1 minus the probability of 10. Okay? So let me see if I can shed some light. Think about the success. As we said, success can varies from 0 to 1 to 2 successes, 3, 4, 5, 6, 7, 8, 9, and 10. So if you're asked the probability of at most 9 successes, معناتها we are interested in all of those. So to save up time, knowing that you already know from previous discussions that if you add up all the possible outcomes, that is going to add up to 1. So instead of calculating each one of these and adding them up to reach the probability you're looking for, you know that everything adds up to 1, so you do 1 minus the probability of x equals 10, and that will give you the yellow highlighted. Okay? However, if you're asked to the probability that at least one, يعني 1, 2, 3, 4, 5, 6, 7, all the way to 10, you're going to use the same kind of rationale, but this time you're going to do 1 minus the probability of success equals 0. Okay? Okay. To know what is the most likely thing that could occur, so if you want to know, if you were to calculate all different probabilities, which one has the highest probability, you can use this formula where it's the number of trials times the number of successes. Okay? So again, going back to the example of traffic light, and a traffic light is green 35% of the time. There are 7 traffic lights. What is the most likely thing to happen? How many greens you think you're going to go through? Well, according to the formula, you take the number of trials, which is 7, you multiply it by the probability of success, which is 35, and that gets you to 2.45. So the most likely thing that is going to happen, or if you were to calculate all the probabilities, the highest probability is for x equals 2. And here I'm doing that. I'm calculating the probability of none is green, 1 green, 2 green, 3, all the way up to 7. And if you add up all these probabilities, they're going to add up to 1. But notice how this one has the highest probability. Yani this is the one that is most likely to occur. Closely followed by the 3, which is, we shouldn't be surprised because the number we got here is 2.45, yani between the 2 and the 3, but it's closest to 2. So the highest probability is going to be for 2, followed by 3. Also, something about the binomial, when the probability of success equals the probability of failure equals to 50%. I mean دايما لما probability of success equals to probability of failure, it's 50% automatically, like flipping a coin, or مثلا gender, boys and girls. Okay? Then you get a symmetrical distribution of the binomial probability distribution. Okay, look at this example. Again, I'm going with n, and number of trials being 7, and the probability of success equals probability of failure equals 50%. You can think about this a family of 7 children, and we're looking at the number of boys and girls, or you can think about this like flipping a coin, show the probability of getting a heads. Okay. So the probability of no heads, probability of only one head, probability of 2 heads, 3 heads, 4 heads, 5 heads, 6 heads, 7 heads. Okay? Notice that the probability of no heads is exactly the same as the probability of all heads. يعني لما بتقول no heads, all of them were tails. The probability of 7 tails is exactly is the probability of 7 heads. The probability of 1 head, 6 tails is exactly the probability of 6 heads, 1 tail. The probability of 2 heads and 5 tails is exactly the probability of 5 heads, 2 tails. And the probability of 3 tails, 3 heads, 4 tails is exactly as 4 tails, 3 heads. the probability is symmetrical. لأنه the probability of success is exactly the same as probability of failure. بيصير في عندنا symmetrical distribution of the probabilities. Okay. يعني probability of um, 3 boys 2 girls هي زيتا 3 girls 2 boys. Okay. Same exact thing. All right, so that concludes the lecture on the binomial probability. We will do some applications in class, hopefully. Thank you for your time.